Today we will be modeling using geometric series. So modeling with geometric, or I should say geometric sequences and series. We're going to be using both. And just a reminder of what geometric sequences and series are. Geometric sequence is a list of numbers where they have a common ratio. So you're multiplying by same number. Multiplying by the same number to get the next term. So you multiply by 3 here. Again, you multiply by 3 here. So remember, for arithmetic sequence, you had the common difference, in which case you added the same number each time. For geometric sequence, you multiply the same number. And geometric series, as you might have guessed, you're just simply adding all the numbers. Put a dot, dot, dot here. Okay, and we know the formula for both of these to get the nth term. So to get the nth term of a geometric sequence, it was a to the nth, or the nth term, equals the first term times 2, or sorry, not 2 in this case. It's going to be the common ratio. R to the n minus 1 power. Okay, so R stands for the common ratio. And for geometric series, it would be the sum of the first n terms. And that would equal the first term times 1 minus R to the nth power over 1 minus R. And if you're wondering how these formulas are derived, then you can refer back to our lesson on geometric sequences and geometric series. We've went over how these formulas are derived. But for this lesson, let's just remember that these are the formulas. So this is to find all the sum, or sum of all the terms until the nth term of a geometric series. This is to find the number on the nth term, or as the nth term of a geometric sequence. Okay, so let's look at one of the problems that we have here. Right, a certain bacteria multiplies by 2 every 30 minutes. If there were 2 bacteria at 1 p.m., how many bacteria will there be at 3 p.m. of that same day? Now, the numbers here are not very large, so you can kind of just do this in your head instead of using formulas. But just so that I can show you how to do these, I'll show you how to do these using formulas so that you can do them with large numbers as well. Okay, so the first thing we should do, it's similar to when we are modeling with arithmetic sequences and series. You need to get a good picture of what's going on here. And a good way to do that is to write the first few terms. Okay, so let's look at this is in 30-minute intervals. So let's write this in 30-minute intervals, since the bacteria multiplies by 2 every 30 minutes. So at 1 p.m., that's when we're starting. There were 2 bacteria. And then at 1:30 p.m., it doubles, or it multiplies by 2 every 30 minutes. So there's going to be 4 at 2 p.m. 2 p.m. there's going to be 8. At 2:30 p.m. there's going to be 16. And at 3 p.m. there's going to be 32. Yeah, so since we were working with a really small number, we already arrived at our solution without having to use any of the formulas. But if this was a longer time, or so, if that was like 11 p.m. or something, how would you be able to solve this? Well, first of all, this looks like a geometric sequence. Right? We're multiplying by the same number each time. This is not an arithmetic sequence because the difference is not the same, but the ratio is the same. Okay, it's being multiplied by 2 each time. So it's geometric. And how do you know if it's a sequence, or if it's asking for a sequence or a series? By looking at the question. And it's asking how many bacteria will there be at 3 p.m. Okay, so it's only concerned about the number of bacteria at 3 p.m. It's not concerning, or it's not asking us about adding all the number of bacteria from the previous times together. It's just asking us how many bacteria will there be at 3 p.m. So this is going to be a sequence, which means that we're going to be using the formula. The nth term of A, of A is going to be the first term times the common ratio to the n minus 1 power. Okay, so let's say we wanted to find the 11 o'clock p.m. 11 p.m. Okay, we need to find, if we want to find how many bacteria will there be at 11, we'll need to assign an n to this time, right? So this is going to be n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, right? And if we keep on going, how many intervals are there between 3 and 11? Well, if you think from 3 o'clock to 11 o'clock, that's going to be 8 hours, right? That's 8 hours in between. But since we're counting for 30-minute intervals, how many 30-minute intervals are there in 8 hours? Well, for each 1 hour, there are 2 30-minute intervals. So that means there's going to be 16 30-minute intervals between 3 and 11. Right? So there's going to be 16 more steps from n equals 5 to get to 11, which means 11 is going to be 5 plus 16, which is 21. So n is 21 at 11 p.m. So let's get the 21st term. That's going to be the first term, which in this case is 2, times the r, common ratio, which is also 2, and n minus 1. So that's going to be 2 times 2 to the 20th. But since these have the same base, we can combine them again. 2 to the 21st power. And if you do that on the calculator, you're going to get 2,097,152. So this is how many bacteria there will be at 11 p.m. if it continues increasing at the same rate. Okay, let's look at another problem here. Oops. Okay, so here we have Mr. Po's salary increases by 30% every year. If his annual salary was $50,000 in his first year at work, how much total money does he receive after 5 years? So let's write out the first few terms to get a good picture of this problem. So on the first year, he receives $50,000. That's his annual salary. Then we have the second year. On the second year, he gets 30% more. It increases by 30%. So you can either think of this as the annual salary plus 30%, but I think an easier way would be just to the salary times 1.3, which is 130% of the original salary. Because for percent increase, you add 100% and change that to a decimal and just multiply. Okay, so this is how much he gets on his second year. On the third year, you're multiplying 1.3 again to his salary on the second year. So you're multiplying 1.3 to this. Or, now this becomes 50,000 times 1.3 squared. Okay, so now you get the picture. On the fourth year, it's going to be 50,000 times 1.3 cubed. And on the fifth year, it's going to be 50,000 times 1.3 to the fourth power. Okay, and this looks to be a geometric sequence because you're multiplying 1.3 each time. You're multiplying the same number times 1.3. And is this a sequence or a series? Or is the question asking for the sequence or the series? Let's look at the question. How much total money does he receive after 5 years? So now this question is asking, after it's been 5 years, how much total money does he make? So it's actually asking us to add all the money that he made during those 5 years. So this looks like a geometric series, not a sequence. We're adding all the previous salaries together. Okay, and what was the formula for the geometric series? It was Sn equals the first term times 1 minus r to the n all over 1 minus r. So this was the formula for geometric series. And let's see if we can identify each of the terms here. So it's asking for after 5 years, so it's asking for until this time. So n would be 5. A1 is going to be 50,000. That was the first term. Then we have 1 minus, the common ratio is 1.3. That is raised to the 5th power. And then we have 1 minus 1.3 in the denominator. Okay, so let's try and do this in a calculator and see what we get. 1.3 to the power of 5, 3.71293, and then do 1 minus that. We get 50,000. I'm just writing the middle step here. Negative 2.71293, and then the denominator is going to be 1 minus 0.3, which is, or 1 minus 1.3, which is negative 0.3. And let's try that on the calculator. That is 50,000 divided by 0.3. And this comes out to be, let me scooch this a little bit this way. Okay, this comes out to be $452,155. So this is how much Mr. Poe earned during 5 years. This is all of his salaries combined. Okay, this is not just the 5th year. It's all the money that he made during those first 5 years. Okay, so this was a geometric series question. And you can use the formulas that you know about geometric sequences and geometric series to solve these kind of questions.